Hello and welcome to a new case, and it's a free case done by Harry Watson from the UK in honor of P or Pi, however you pronounce it. So this beautiful number, and it was I think 11 days ago, so yeah, cool case. Let's jump right into it. For each value of n, what is the nth decimal place of pi after the decimal point? Okay, here is pi. I don't have the number, but you could also look it up in the internet. And I want to replace this with 1. This takes some time. Yes, and now I need a by, needed only here, by row. Maximum 10. No, maximum 9 spaces. And I want to have the sum. Here. Okay, I need to drag it down. It goes until, oh, that's a lot. 800, 1000. Yeah, I think 1000 decimal places. Okay, and now I want to have an index of this, returning, make it absolute and returning the row number. Yeah, okay, should be fine. Oh, there's no solution to this. Interesting. At what point do the following sequence of digits first occur in pi? Okay, so I need to concat this here. And with pi, and then search for this in pi. Okay, should be fine. The pi shifter. We assign letters to a value for each letter. Look at the value and where it first occurs in pi. Okay, 16. Okay, this is complicated. Example 3. P has a value of 16. 16 appears at 40th place, somewhere here, and then it shifted. And what is CG? C. Oh, create this common divider between 8 and 16. Between 16 and 40 is 8. Okay, I think I want my lambda, or my lambdas, to at least have the shifter in. And now, split text, and then code minus 64. Or, okay, make it in steps. So let SP yes, and I know them, it's not the right way. I have no separate input value. Okay, for it's alright. And then the first occurrence of this is search C in pi 1 to 3.1. Okay, it's alright. And then greatest common divider between C and O. Okay, it's not dynamic. C is an array, O is an array. Map OC lambda A B GCD A B. Now we have it mapped. Is it 8 and 1? No, 9. Okay, yeah, it's fine. And then it's chiffre letter is SP, offset value is this, and then concat it. I hope it will not get more complicated. I don't think that I can adjust it that easily, but let's see. It's somehow cryptic. Okay, is there? No. No answers. Also here. Crazy. Okay, let's go deeper into the case. The seventh number of pre-imagines. Crazy. Okay, the issue with the pi shift is that encrypted. Is it 7 levels? Oh, 5. Oh, thank God. With the pi shift is that an encrypted message is not always well defined. So deciphering it can be done in multiple ways. How many other text strings? Oh my gosh. 2 letters maps to T. Oh. So we need every letter. A to Z. And we now need to find out or shift it once. So in this case, we adjust our formula. And then, yes. Okay. We could group by it. Group by count A. Okay, we have some letters that are not in there. So list not in list array, large list. Okay, large list is this, list an array, so I can use the here, and here are all our letters. Okay, those letters are not in there, and there's a, so this should be 0. But the question is, the answer cannot be 1 and 0. Okay, let's split this. So T, so we need the product of this splitted and looked up. So product x lookup text split. Oh no, mid sequence split. Use my lambda for this, and then we want to look up in here, returning the numbers. NA accurate. If not found 0, of course. Let's drag it down. Okay. Should be alright. Yeah, I will not do this single formula, but you get the idea. Now, multiple pi shift. In each case, we will take the given string and apply the pi shift a given number of times. Okay, we shift. How many different text could be pi shifted that many times to get this same answer? Okay. I hope I can get the answers to this case somewhere. Because I'm interested, but let's do this first. Okay, okay, we know okay, so we shift this 4 times. Okay, scan this, use this formula and scan it. Scan initial value is this, sequence 4, lambda a b, vstack a, oh no, we don't need this, it's not a reduce, lambda a b concat, and this is then a, close, done. So it shifts to G. Okay, but the question is, it will also do it with a text. But then the question is, what is then the answer? I think it's then. What is G? G is 1. Or in total, which yield G? G is 1 here, not 3. Huh. Okay. Yeah, I got it. So I need to count the pi shifts after the certain number of levels. The question is, what is then the answer? Okay. Okay, I need a reduce here. Oh god, this will get messy. Okay, this is my shift formula. Okay, let's make this a lambda. Shift equals lambda x. That's a problem with this editor. It's super bad. But yeah, and also this will not work. Okay, one. Okay, and now we have a shift lambda. Okay. Scan shift A. Done. Okay, it's now way more compact, and I now need to reduce this and use group by on it. Okay. Reduce initial value is the whole alphabet. Okay. Now I then need to reduce this and make a lambda out of this. A, B, A, B. This work? Oh no. Yeah, that's the problem. C, D, C, D. No, will not work. Ah, yes, of course. I'm dumb. I need to give it arguments, and then I can go back to AB. Okay, done. Now name this shift. Shift or scan shift. Scan shift. So I can scan shift use here. Oh, bad. Manage names. I want to input there something. Close. Scan shift. A, B. And I get a value. Okay. Now. And this is then scan shift of the alphabet. Scan shift A to Z vertical. It could be that I need to map this in, but let's see first. Oh no, but it's concatenating everything. And there are G's, but 1, 2, 3. The question is, what is then with this here? Apply the shift to give a number of times. We know what now want to know how many pre-images the result has under P shift. How many different texts? Pool. Okay, so this is basically then this. Okay. Count letter in text. I don't know if this will work. Oh, it has worked too. And then group by, oh no, I don't need to group by, because I have already counted it. So I then need product of char index of split. Product index of this row number is row number is char split text into letter array, and with the live stuff I'm not that code, not char, sorry. Also not value code of splitting this, and then this should be after the bracket 0, which is wrong. Okay, let's find out what the code is. 65. Yeah. Of course, of shift or scan shift. Scan shift here, and this 4 times, of course. The answer is 3. And now, yes, everything which is non-dynamic is non-dynamic. These numbers look somehow in the range of possibility. It's a lot, but I don't know, should be alright. Let's go to the bonus questions. Okay, I don't. Harry, you're too much of a mathematician. Oh, there's a reference. So there was somehow. Okay. If the pi shift is applied indefinitely, we actually end up in an orbit of letters. What is topological transitive? I don't know. If the pi shift is applied. Okay. I scan this. Start with letter A. And sequence is 1/10,000. Lambda A B shift A. And the question is if there's some sort of oh yeah, there is. I think this is like the don't know the English term. Yeah, the thing you will see. So 11. It's a repetition of 11 letters here until the B, and I think there are only unique letters in here. Unique. Yes, 11. So the answer is 11. Yeah, I know. I hopefully will find the answer somehow. Of the words in the wobble word list, how many do not have any pre-imagine under pi shift? Okay. So pre-imagine is and what was the question? How many do not have any pre-imagine? So how often is the answer 0? I guess. How many other text strings? When oh no, when the answer is greater than 1, I think it's pre-imagine, but I'm not 100% sure. So yes, I know. I know. Oh no. Yeah. Look up here. Returning this. And if you may not know it at that point, Harry is a mathematician. Yeah, too bad. 0. Okay, count if larger than 1. I don't know if this is the answer, but 895. Of the words on the how many have well-defined pi shift? 1, predetermination, nothing else, so count if 1. Okay, let's see. Now the last bonus question. What's the difference to 3? How many have a practical? Well, we will define this as any word whose pre-shift output has only one. Has a only one. Huh. Is this English? Dessen P-Shift-Ausgang als einziges Vorbild. Okay. Is this then 2, exact 2? I have no idea. I have no clue. But yeah, I will quickly search for the answer somewhere. I hope that I will not need to go to DIMS or Bose video, but let's see. Okay, so I'm back. I tested this one with DIMS answers, and those answers are wrong. I also did not spend enough time to understand what is asked. And some of level 5 are wrong. I don't know exactly, so only some. So for example, some are right, some are wrong. So here the 144 and the 1 is right. This is wrong. The question is why? but I need to further investigate there to get to an answer. So also here, the 243 is right, but this is like 18. It's wrong, and there should be 144, so something went wrong here. But nothing I can find out in a super short amount of time. Oh, no, I actually can find out. I'm idiotic. I all the time went to this shifter. Ugh. And here, this should be then dependent on this. 144, 162. Okay. Yeah. So the problem was that I was always referring to this shifter here, which is for the example, but not for these separate game levels. But anyways, so this is then right. Yay. And now for the bonus points, I refer to Dim's video. I first need to like it. I haven't seen it before, so. But yeah, the first one is alright, but then here it's getting a little bit more tricky. So yeah, sorry for that. I need to have more time to dig deeper, but anyways, thank you, Harry, for this case. It was a pleasure. As always, a little bit of a mind struggle, but yeah, I think census so far was not that mathematic, but the other cases were highly mathematic. But it's good, it's good. So thank you. And if you want to see good solvages of this case, I refer to Dim or I think also Bo has solved it another video. So especially for the bonus questions which are like what is 81 divided by 341? Okay, so under 1/4 of the overall points. So anyways, thank you for this for your attention. And here I know it was a few days ago, but happy Pi Day. Thank you. Bye.